Near Protocol is a Layer 1 blockchain designed to make decentralized applications fast, usable, and scalable without sacrificing security. Its core idea is that a single monolithic chain eventually hits throughput limits, so Near scales horizontally with a sharding design called Nightshade. Instead of splitting the network into fully independent chains, Nightshade keeps one blockchain with a single logical state and represents shards as chunks of each block. Validators are assigned to shards to produce and validate these chunks in parallel, and the protocol assembles them into a single block for finalization. Because the chain remains logically unified, developers interact with one network while the protocol transparently balances load across shards. This is paired with Doomslug, a leader-based mechanism that gives fast, practical finality by having block producers sign and acknowledge blocks in rounds, so under normal conditions transactions feel final within seconds. NEAR's account model is built for usability. Accounts are human-readable names instead of opaque hex strings, and every account is a smart contract account by default. Access keys make permissioning granular. A user can create a limited permission key for a single app with spending caps, while keeping a full access key offline. This removes common wallet friction and enables smoother web-like onboarding flows. On the execution layer, Near compiles contracts to WebAssembly, so developers can write in Rust or TypeScript and deploy to a deterministic WASM runtime. The runtime supports asynchronous cross-contract calls natively. When a contract on one shard calls another on a different shard, the protocol passes receipts that resolve in later blocks, letting developers compose complex workflows without locking the whole chain. Nightshade's dynamic resharding allows the network to split or merge shards based on load so capacity scales with demand. Validators stake the native token to participate in consensus. Selection uses an auction-style mechanism that targets decentralization by encouraging many validators rather than a few very large ones. Misbehavior can be penalized with slashing, aligning incentives around liveness and honesty. Fees are paid in the native token and a portion is burned while another portion funds a protocol treasury, linking network usage to a lower long-term supply trajectory and sustainable development funding. To connect with the broader ecosystem, Near offers Aurora, an EVM-compatible environment that runs on NEAR's infrastructure so Solidity apps can deploy with familiar tooling while inheriting NEAR's throughput and finality. For asset and data movement, the Rainbow Bridge uses light client verification to pass messages trustlessly between Near and Ethereum. Rather than depending on a multisig, each side verifies the other chain's headers inside smart contracts, which increases security albeit with settlement times dictated by the underlying chains. From a developer perspective, the Cosmos-like perks are complemented by web-style ergonomics. Predictable fees, storage staking that associates state size with a token deposit, and contract-level upgrades governed by the account owner, all tied to on-chain governance for protocol changes. Because Nightshade keeps one logical chain, state remains globally addressable even as shards operate in parallel. The trade-off is that developers design for eventual resolution of cross-shard calls, which Near embraces with patterns for promises, callbacks, and idempotent logic. As usage grows, the protocol can increase shard count to maintain throughput targets while Doomslug maintains user-perceived finality. In practice, this architecture aims to deliver low fees, fast confirmations, and a developer experience that resembles building for the web, with the security properties of a proof-of-stake blockchain. The broader vision is a network where consumer-grade apps feel intuitive, onboarding does not require complex key management, and scaling happens under the hood via resharding rather than migrating to new chains. NEAR's roadmap continues to refine Nightshade, expand validator participation, improve bridging and EVM performance, and deepen the economics that link fees, burning, and treasury funding to long-term sustainability. If the thesis holds, a sharded, WASM-based L1 with human-readable accounts and asynchronous composability can host mainstream applications without fragmenting liquidity or abandoning decentralization. For more insights on Near Protocol, sharding with Nightshade, and WebAssembly smart contracts, remember to like, subscribe, and keep learning, here at Crypto in Black and White.